Here's how you factor trinomials that have a values that are not equal to 1. As a review, all trinomials can be written in the form ax squared plus bx plus c, where a is the coefficient of the x squared term, b is the coefficient of the x term, c is the constant. In this case, a is equal to 3, b is equal to negative 2, c is equal to negative 5. When we have trinomials that have a values that are greater than 1, we need to look for factors that multiply not to be c, but multiply to be a times c. Since your a value is greater than 1, the new procedure is that you first have to figure out what is a times c. In this case, a is 3, and c is negative 5, multiply to be negative 15. We have to think about all the integers that multiply to be a negative 15. Consider all your options. These are the ones that I can think of. 1 times negative 15, negative 1 times positive 15, 3 times negative 5, negative 3 times positive 5. And the other consideration when you're deciding on your pair of numbers to use is that they also have to add up to be b value. In this case, the b value is negative 2. 1 plus negative 15, not going to do it for you. Negative 1 plus positive 15, also not going to do it for you. 3 plus negative 5 is negative 2. That's the pair that we're going to use. Negative 3 plus positive 5 is positive 2. That's not the b value. We're not going to use that. So the pair of numbers that we're going to be utilizing is 3 and negative 5. 3, your original trinomial. And what we're going to do is we're going to break apart our middle term. Our middle term is negative 2x. We're going to break this apart using the pair of numbers that we found. So the first term comes down as is. And then I'm going to put plus 3x minus 5x. And bring down the minus 5, the constant term. The reason why I used 3x minus 5x is because if you combine those terms, you would get the negative 2x. And also the reason why I'm using those numbers in particular is because our pair of numbers that we used that I circled over here was 3 and negative 5. The next thing that we're going to use is a concept called factor by grouping. First, I'm going to look at these first two terms, 3x squared and 3x. And I'm going to pull out the greatest common factor. The greatest common factor of 3x squared and 3x is 3x. I know that I could divide out a 3 out of both of the terms because that's the greatest common factor of the coefficients. I know that I could divide an x to the first term out of each of those two because we have x squared and we have x to the first power. And you could always pull out the lower exponent of the variable you're working with. Now what we have to do is divide that greatest common factor out of the terms that are in these first two terms. 3x squared divided by 3x is going to be x to the first power. The plus sign comes down. 3x divided by 3x is a 1. With another color, I'm going to group together my next two terms. There's a minus sign starting off those two terms, so I'm going to bring down a minus or a negative. And then I'm going to look at the 5x and the negative 5. And I know that I could divide out a 5 out of both of those terms. And consider what's left. Negative 5x is being divided by the negative 5. So there will be an x left. Negative 5 divided by negative 5 is a positive 1. So there's an x plus 1 in parentheses. And using the distributive property, we could check that this new expression is exactly the same or equivalent to the expression before it. What we have to do next is realize how each of these, when we did the factor by grouping, each of them had in parentheses a common term, x plus 1, and that could be brought down to the next line you would only write it once, but you would bring down the common term, which is one of the factors. The other factor is formed by whatever is in front of the parentheses. There's a 3x in front of this pair of parentheses, and there's a minus 5 in front of the other pair of parentheses. Therefore, our answer, or our two factors that multiply to be that original trinomial, are right here. I'm boxing them in. 3x minus 5 and x plus 1. We can check by using the FOIL approach or the double distribute approach. Here's another one. In this case, the a value is a 2. Since it's in front of the x squared, the b value is, the b value is a 3 since it's in front of the x, and the constant is a negative 9. And since the a is not 1, we use the procedure where you have to multiply to be 8 times the c value. A value is 2, multiply it by the negative 9, which is the c value, that's a negative 18. On the side of your paper, consider all the different ways of having two integers multiply to be negative 18. One and negative 18, 1 times negative 18, negative 1 times positive 18, 2 times negative 9, negative 2 times positive 9, 3 times negative 6, negative 3 times positive 6, and those are the only ways that I can think of right now. We also have to have those pair of numbers multiplied to be a times c, which we already considered, but add to be the b value, which is a 3. These are not going to work, these are not going to work, these are not going to work, not going to work. The bottom two we have to narrow down. We have a 3 plus a negative 6, or a negative 3 plus a positive 6. And the way of getting a positive 3, remember how our b value is a positive 3, is this final pair of numbers, a negative 3 and a positive 6. Negative 3 plus positive 6 is equal to a positive 3. Rewrite our original trinomial. And again, this middle term is going to break apart using the pair of numbers that we found here. 2x squared plus 6x minus 3x minus 9. And if I was to take 6x and subtract off 3x from it, I can combine those terms to come back with our original 3x in the middle. So I know that I chose the right equivalent terms. Now we have to factor by grouping. Group together these first two terms. 2x squared plus 6x. We could definitely factor out a 2x, leaving us with x plus 3. In our second set here, I can bring down the minus sign, since it starts off with a minus 3x. And I can factor out a 3 out of both of these terms. Negative 3x divided by negative 3 is a positive x. Negative 9 divided by negative 3 that we factored out would be a positive 3. Notice how there's a common term again, and that should always happen when you do factor by grouping. In parentheses, we have a common term, x plus 3, that we can bring down, and it is only written once. And in front of the common term, the other factor is formed. There's a 2x in front of the common term in our first pair, and in our second pair there's a minus 3 in front of the common term. Here are our factors. When we multiply these binomials out, we would get back our original trinomial.